This video is on even and odd degree functions. Now, an even and odd degree function refers to whether the degree of the polynomial is an even number or an odd number. Now, here's a couple of things. One, we're really focusing on the fact that we are talking about degrees, because in a week we're going to have even and odd functions, and that's something totally different. So every time I mention even and odd numbers today, I'm going to be talking about even and odd degrees of polynomials. Now, if you remember, the degree of a polynomial is the largest exponent of the polynomial, and so we are always going to be focusing on that number and whether or not it is an even or odd number. We look at this because there are things we can tell about the graph of a function just by looking at that number. So go ahead and grab your calculator. I want you to enter these equations into y equals. Go ahead and hit pause while you do that. When you're finished, hit play again. Alright, so the first thing I want to know is, what do all of these equations have in common? Hopefully you noticed that the degree of each number, or the exponent of each equation, is an even number. Okay, so all of these are even degree functions. Go ahead and hit graph. This is what all of your graphs should be looking like. Now, what do all of these graphs have in common? Hopefully you notice that each graph has a parabola shape. The end behavior on both sides is going in the same direction. Okay? Now, this is what happens when our degree of our polynomial is even. We have what we call a parabola shape. Now, what would happen if we went back to our equations in y equals and we put negatives in front of each one of them? Without doing it, what do you think would happen? If you remember from our transformations, what's going to happen is all of these are going to reflect over the x-axis. So a positive even degreed function is going to have end behavior that goes up on both sides, and a negative leading coefficient is going to make it flip where the end behavior on both sides is going down. Okay, now clear out your y equals, and I want you to put the following equations into your calculator. Go ahead and hit pause, get those in there, and then hit play again. So what do all of these equations have in common? Hopefully you're noticing that all of these degrees are odd numbers. And go ahead and hit graph. This is what they should look like. So what do you notice about these graphs? Think end behavior. Hopefully you're noticing that the end behavior on each end is going in opposite directions, unlike the even degree functions that they go in the same direction. Okay, now what do you think would happen if we put a negative in front of each one of those equations in y equals? Okay, so a positive leading coefficient is going to have a shape like this, where the right side goes up and the left side goes down. If we do have a negative coefficient, it is going to flip and look like this, where the right side goes down. Okay, now we are going to call this a cubic curve, the shape, just so that we don't have to describe this squiggly line, okay? So all of these have what we are going to refer to as a cubic curve shape. So let's do some examples now. What can we actually tell from all this information? Well, let's look here. We have g of x, and we want to know what the degree of the polynomial is. Well, I have got an understood 1 here, I have an understood 1 here, and I have a 2 here. So 2 plus 1 plus 1 gives me a degree of 4. Now, is 4 an even or an odd number? That's even. Okay. Now, let's think about looking at your notes. An even degree function has a parabola shape or a cubic curve shape. It's going to be a parabola shape. So what is the sign of the leading coefficient? Well, if we multiply this through, we've got a negative and an x times an x times an x squared. So a negative, just a second, a negative times an x times an x times an x squared is negative 1, 2, 3, 4, negative x to the 4th. My leading coefficient is a negative 1. So it is a parabola, but it has a negative in front of it. So it is going to look something, or the end behavior is going to be down like this. Now, if I look at my zeros up here, we already know that we have a 0 at negative 2, we have a 0 at positive 4, and we have a 0 at negative 3. Okay, so I can go. Now remember, this is our multiplicity. We just learned that, so it's going to bounce off of that. Let's adjust this piece over here. Okay, so now just by looking at the degree, I know this is what the end behavior has to look like. Okay, let's go ahead and go to the next example. Here, what is my degree? This one is in standard form. It's a little bit easier to see. So my degree is 5. That is an odd number. And the sign of my leading coefficient is 3, so that is positive. Now because it's odd, that's going to give me a cubic curve. I know that my y-intercept is going to be at 7. 1, 2, 3, 4, 5, 6, 7. It's an cubic curve, and the right side is going to be going up, and the left side is going to be going down. Now this may not be exactly what this graph looks like, but what I do know is this is what the end behavior looks like. Okay? That's what we can do with even and odd degrees of polynomials.